Now we will study combinatorial identities, or I can say combinatorial arguments. So basically, this is the idea. The idea is this. Okay, from now onwards, this is the idea. Always listen to the both sides of a story. Every story has two sides. Okay, so just listen to both sides of the story. Or I can say, what is combinatorial argument? What is combinatorial argument? Make a story. Think about it in two ways. Everything you think in two ways, two different ways. For example, in the last class, we have already done this. This is your scenario number one. NCR equal to NCN minus R. What is the proof? The algebraic proof. The boring algebraic proof. What is that? Algebraic boring proof. Boring idiotic proof. What is that? How will you prove it? Algebraic proof. How will you do? You know NCR. You know NCR. NCR is basically n factorial divided by n minus r factorial r factorial. This is your NCR. And what is NC n minus r? What is NC n minus r? NC n minus r is basically, that is n factorial divided by n minus r factorial. So that is r factorial, n minus r factorial, and they are same. This is your, okay, correct? Yes or no? This is your boring proof, algebraic proof, because both are same. NCR is same as NC n minus r. Correct? Yes or no? And NCR, so that will be n factorial, n minus this, because you know n minus this. What is that? That is r. Okay, so this is the idea. Now, what is the combinatorial proof? What is the combinatorial proof? What is the combinatorial argument? Combinatorial argument, or I can say combinatorial proof. This is interesting because this will involve some story. So you can think same thing as two ways. Yes or no? We are thinking same thing in two ways. Think of it in two ways. Okay, so what I can think? Rejection is same as selection. Yes or no? Keeping R elements is same as rejecting. Keeping R elements is same as rejecting n minus r. Yes or no? Keeping R is same as rejecting n minus r. So keeping R, this is same as rejecting n minus r. This is your combinatorial argument. Very simple. Can you notice? This is intuitive. Like this will give you more intuition. This is algebraic argument. This is boring. And this is combinatorial argument. Same thing you can think in two different ways. Yes or no? Keeping R is same as rejecting n minus r. So this is your combinatorial argument. Okay, let's see the next. That is, next is Pascal identity. How to prove it? What is one way to prove it? Can you prove it using algebraic? Using the algebraic proof. Just open it, and add them. This is your algebraic proof. Yes or no? So what is the algebraic proof? Algebraic boring proof. That is very boring. What is that? What is your n plus 1 k? What is that? That is n plus 1 factorial divided by k factorial n plus 1 minus k factorial. And you can check it out. You can check it out. Is this equal to n factorial divided by k minus 1 factorial n minus k plus 1 factorial plus n factorial divided by n minus k factorial k factorial? Okay, just check it out. Very simple. This is algebraic proof. Can you see this is boring? You don't even want to do it, right? Yes or no? I know many of you won't even do it. Many of you won't even check it. This is your algebraic proof. Very boring. Okay, boring, no intuition, no knowledge, nothing. Okay, no intuition, no knowledge, nothing. No intuition. This is just a very boring thing. Now let's see interesting thing. Okay, now this thing, I will create one story, and that story we will think in two ways. Okay, so let me create a story. So to prove this, I will create a story, and that story we will think in two ways. So what is the story? Story is like this. This is our story for Pascal identity. Can anyone tell me what this means? See, I am telling you how to create a story. I am teaching you how to create a story. So tell me what this means. When you look at it, what this means, when you look at it, it means there are n plus 1 people and you want to select k people. So it's like this. There is a class. There is a class in which you have n plus 1 students. Okay, there is a class in which you have n plus students and you want to select k students. You want to select k students. This is your story. Okay, so what is the answer of this story? You have n plus 1 students and you want to select k students. So side 1, if you think about this story directly without any mirch masala, without any twist, if you want to think, then what is the answer? Directly if you think, then answer will be n plus 1 ck. This will be your answer. Agree? Very simple. But now this same thing, side 2, what I can do, I can think, see, there are n plus 1 students. Take a particular student. What you do? Take a particular student. Just take a particular student. Okay, take a particular student you have. A particular student we have. We have a particular student. Let's assume that particular student. For example, let's assume Sandeep. Okay. So in short, let me take it X. So let's assume you have a particular student X. Now this is a particular student. So tell me now you tell me what are the two cases? From this class n plus 1 students, you want to select k student, then a particular student, either he will be selected or he will not be selected. So there are two cases. Either you take X or you don't take X. Either you select this student or you don't select this student. Only these two cases are possible. Agree or not? Only these two cases are possible. Now, so this side 2, either you take X, you have already taken X, then how many ways? You have already taken X. You have already taken X. Then how many ways? From the remaining students, you will select, you have already taken X. So from the remaining students, you will select k minus 1. Or you have not taken X. You are not taking X. You are not taking X. You don't want to take X. So from the remaining students, how many you want to select? From the remaining students, you want to select k. Yes or no? Agree or not? See, here you have already selected X. So from the remaining people, you want to select k minus 1. And here you are not taking X. So from the remaining people, you can select k people. And these two sides of the story, they are the same. Can I say side 1 and side 2 are the same? Same story, we are thinking in two ways. This same story, you are thinking in two ways. So these two sides are same. So finally, I can say side 1 is equal to side 2. So from n plus 1 people, you want to select k people. That is same as you have already taken a particular student. You have already taken a particular student, or you are not taking that particular student. This is your combinatorial proof. So tell me which is interesting, algebraic proof or combinatorial proof? This is your story. Very simple. Yes or no? So I hope you like it. Anyone has any doubt in this? This is known as Pascal identity. This is known as Pascal identity. Same story, you are thinking in two ways. So Pascal identity is like this. From n people, you want to select k people. That is same as you select one specific person. So from the remaining people, you select k minus 1, or you don't select a specific person. So from the remaining people, you select k people. This is known as Pascal identity. We want to take k people. We want to select k people. And you are not taking X. What it means? You are not taking X. What it means? It means from the remaining people, you will take k. Because ultimately you want to take k people. Ultimately you want k people. So if you are not taking X, then from the remaining you will take k. And if you are taking X, then from the remaining you will take k minus 1, because already you have taken X. Is this clear to everyone? This is called Pascal identity. And this Pascal identity, you can see the same thing, the same story. You can increase Using the same story, can you prove some variations? Using the same story, can you prove this? From n people, you are selecting k people. Can I say that okay? So can you prove this? Using the same story, can you prove this? How will you prove this using the same story? How will you prove this using the same story? Tell me. You will take two particular students. So in your story, what you will do? In story, side one is from n people you want k people. From n people you want k people. This is your side one. And what is side two? What is side two? Take two particular student. Two particular student you take. Take two particular student x comma y. Yes or no? Take two particular student x comma y. Now, if you take two particular student x comma y, then what will happen? See, either you can select both of them, like you are selecting x comma y. So okay, select x comma y. Both of them you are selecting. Then how many ways? Total we want k people. Already two are selected. So how many remaining? How many remaining? K minus 2. From the remaining n minus 2, I will select k minus 2 plus. Let's assume I am not taking any of them. Neither x nor y. Neither x nor y. It means what? It means from n minus 2, I will select k people. Yes or no? From n minus 2, I will select k people. One of x comma y taken and another rejected. One of them taken, one of x comma y taken, other rejected, another rejected, another not taken, another not taken. So there are two ways, okay, like whom you are taking. And from the remaining people, you will select k minus 1 people. From the remaining, you will select k minus 1 people. Is this clear? So can you notice? This is variation. Just very simply you can do this. Yes or no? Like similar variation can you create? 3 people. Don't worry. Okay, this is enough. You don't have to create variation for 3 people. But I just want to tell you that this is how you can think. So from n people, you are selecting k people. And this is your side 2 of the story. Side 2. Take two particular students and you think about them. So either you select both of them, you don't select any of them. One of them you take, another you don't take. Is this clear? Tell me. This result clear to everyone? And let me tell you, this is very important. This Pascal identity is very important. And in the GATE exam, they can ask you this Pascal identity is many different ways. This Pascal identity actually in the GATE exam so far, they are not asking variations of this Pascal identity, but I am thinking that they can ask this Pascal identity in form of C program. They can give you a C program and they can ask you. Okay, so let me give you one example. So first of all, you understand this is the recurrence relation. Remember, I told you what this NCR. What is this? NCR. What we call it? Tell me what we call it. We call it binomial coefficient. We call it binomial coefficient. I told you this. And this binomial coefficient, how to find it recursively? This binomial coefficient, how to find it recursively? Okay, so this Pascal identity is the recursive definition of binomial coefficient. Very important. So this Pascal identity, okay, this Pascal identity is the recursive definition. This Pascal identity is the recursive definition of binomial coefficient. So I can say to find out this binomial coefficient, you can find it recursively. So I can say this is your recursive definition of binomial coefficient. Binomial coefficient. Have you studied recursion in C program? Did you study recursion in C program? C programming. Okay, so this is R minus 1. Sorry. So this is r minus 1 r. So this is the recursive definition of binomial coefficient. Now in the GATE exam, how they can ask you this? First they can ask you what is the recursive definition of binomial coefficient. So you know this is the recurrence relation for binomial coefficient. Okay, so this is the recurrence relation you can notice. In the GATE exam, they can give you a program and they will not mention that this is a binomial coefficient. What they can do in the GATE exam, what they can do something like this. Okay, so they can give this type of program. They can give, maybe they can create a function. Okay, they will create a function f fun. They will create a function fun, and what they will do, they will recursively, they will call it. This type of question they can create. See, okay, this type of question they can create. They can create a fun function, and what they will do, there will be a main function. In this main function, what will happen? There will be integer k comma n and something like this, and they will call this fun. They will call this function n comma k. This fun will they will call, and they will ask you what is the return value. So they will call this function. Maybe they can call this function. For example, int k equal to 2, int n equal to 5, or maybe k equal to 3 and n equal to 10. And they will ask you this. Now, can you think? Okay, just tell me this point. In the GATE exam, you don't know this is binomial coefficient or not. So just think about it. How will you solve this question? Before today's class, if I give you this question on your screen, how will you solve it? Unfolding, tree, unfolding. Okay, how much time it will take? Just think about it, how much time it will take. Let me tell you, a lot of time. It will take you a lot of time. If I change this value, k equal to 6, or maybe k equal to 7, now you will just keep doing. Just think about it. If I change it to 20, now tell me how much time it will take. Now tell me how much time it will take. Are you getting my point? See, in the GATE exam, whenever some complicated question comes, then definitely there is very easy method. Many times this will happen in the GATE exam. If there is a question which can be solved in 10 minutes, then definitely, and like most probably there is a method which can solve that question in 10 seconds. 10 minutes versus 10 seconds. So you can notice this question, and this is a strong possibility because this is the binomial definition, binomial coefficient recursive definition. So remember this point. This is the recursive definition of binomial coefficient. This binomial coefficient you can find recursively. NCR is equal to n minus 1 CR minus 1 n minus plus n minus 1 CR. So if I give you now, from now onwards, if you see this question in the GATE exam or in any exam, if this question comes, now you can check. When you see this, automatically in your mind, what will come? What will come in your mind when you see this? What will come in your mind when you see this? Binomial coefficient. This is the recursive definition of binomial coefficient. It will come in your mind. This is the recursive definition of binomial coefficient, NCK. Okay, I hope this point is clear. So that is the idea. Okay, so anyway, so they can ask you like, okay, this is actually a question, let me tell you. So this question I have taken from a university. So in that university, this question is given. But actually they are mentioning binomial coefficient. But if they don't mention binomial coefficient, like here, if I don't mention binomial coefficient, I mention some function fun. Okay, then the problem will happen. So when you see this, now what will be the answer? Tell me. Now what will be the answer? Now tell me the answer. Now you already know the answer. What is that? That is 20C 17. That is 20C 3. And that is your 20 multiplied by 19 multiplied by 18 divided by 6. This is your answer. Okay. Is this clear? So very easily you can find. But if you solve this question by unfolding, if you make a tree, if you unfold, it will take lifetime. You cannot solve this question if you do unfolding. You cannot solve this question in the GATE exam if you do unfolding, if you make a tree. And someone else will do this in only 1 second. So maybe Go classes students can do it only 10 seconds. And if someone is not aware of this, then maybe it can take, a lot of time. Okay, so anyway, so let's move on. So basically, whenever you create a story, okay, so we will create 2 3 more story we will create, but whenever you create a story, these are some ideas. These are some ideas. So basically, you have LHS, RHS, they are different expression. So what you do, you think about them in 2 different ways. So you think this LHS and RHS, you create a story, and for that story, you create 2 sides. Okay, so how can you prove this? How can you prove this? What story should I create? Let's create a story for this. See, from this you can create a story. Just think about it. Just think about it. What story you will create? Let me create a story. That there are M men, M boys, N boys, and M girls. Okay, so let's assume this story I can create. I can create this story that there are N women, there are M men, and you want to select R people. And you want to select R people. That's it. Once you create this story, everything is done. Everything is done. Just create this story. Yes or no? So there are N women, M men, and you select R of them. So what is side 1 of this story? Side 1. So total people are these, and you are selecting R people. This is your side 1. So total people are N plus M, and you are selecting R of them. This is side 1. Tell me the side 2. Please tell me the side 2 by looking at this. Side 2. Make the cases. Side 2. What is the side 2? Side 2 is like this. What do you do? 0 women. Side 2 is like this. 0 women. So all the are men. All the are men. Or 1 women R minus 1 man. Or like this, and so on. Or and so on. I can say are women and 0 men. So like this, very simple. So finally, this side 2, what it will be? From N, you select 0 women, and from M, you select all the R men you select, plus 1 women you select, okay, and R minus 1 man you select, plus 2 women you select, R minus 2 men you select, or and so on. R women you select, 0 men you select. That's it. Yes or no? Tell me. This is your proof. That's it. Side 1 is equal to side 2. So you can notice NCG, this both are same. Yes or no? This is your proof. Tell me, did you get it? This story. So this story we are creating, that N women and M men are there. Select R people. Side 1 of this story is this. Side 2 of this story is this. So you have 2 story. So finally, I can write like this. So you have N plus M, and you want to select R people. I can call it, basically what is happening, from N women I am selecting K women. Then from men, how many I will select? If I am selecting K women, then from men, how many I will select? Then from M I will select, sorry, R minus K. I will select R minus K. Okay, and you can notice this K is going from where to where? You can notice this K is going from where to where? This K is going from 0 to R. This K is going from 0 to R. This is known as, this thing, this identity is known as Voldemort identity. This is Voldemort identity. Or you can call it Voldemort, or anyway. Okay, this Voldemort, you know who is Voldemort? Harry Potter. Okay, so this is your Voldemort identity. So did you understand this Voldemort identity? Very simple. This is your Voldemort identity. M plus N. So there are M men and women, and okay, you are selecting R people. Then you can think like this. This is your story. Very simple. So this type of question they can ask you from this. This type of question they can ask, like 52 C10. Okay, this type of question. For example, they can ask you, what is 30 C12? Okay, this is equal to what? Yeah, tell me, is this correct? Can I say they are same? Are they same? No, this is not correct. This is not correct. This is not correct, because why this is not correct? See, Voldemort identity says that you have 16 men, 14 women. Okay, then there should be all the cases. All the cases you should create. So this is not correct. What should be correct? Correct is this. Correct is this, that there are, let's assume there are 16 men. Let's assume there are 16 men and there are 14 women. You want to select 12. So you can select k of them, then automatically 12 minus k of them, and this k can go from 0 to 12. This k can go from 0 to 12. This is correct. Are you getting this point? Okay, so this is not correct. I just wanted to mess with you. So that is the reason. This is not correct. This thing is correct. Means there are 16 men, there are 14 women. From 16 men you are selecting k, and from 15 you are selecting automatically 12 minus k, and this k can go from 0 to 12. This is correct. Is this point clear? This thing is correct. If I do like this, like if I do like this, for example, if I do like this, k, and there is 12 minus k, and this k is going from 0 to 12, this thing is correct. Another way I can do like this. What I can do, for example, I can do 20, and I can do 10, and I can do, here I can do k, then here what should I write? I should write 12 minus k, and this k can go from 0 to 12. Sorry, actually this should be, there is problem here. Is this correct? Is this answer correct? This answer, is it correct? Is this answer correct? Tell me. This is also not correct. This is not correct, because see, okay, this k is going from 0 to 12, but how can 10, like, okay, this should be greater than k, right? This should be greater than k. So this is not correct, but this will be correct. If I do like this, for example, if I do 15, 15, okay, then k, then automatically here you will have 12 minus k, and this is k is going from 0 to 12. This is correct. Okay, is this point clear? So this is the idea. Okay, so in this they can ask you this type of question, they can ask you. What about this? Which of them are correct? You already know the answer. Answer is 1, 2, 3, but you can just check. So basically, these are the different ways of writing the Vandermonde identity. See, in the GATE exam, they can ask this Vandermonde identity in many different ways. See, this M plus N CR, this is the original format. The original format is from N you are selecting K, and from M you are selecting how many? How many? From M you are selecting R minus K, and this K is going from 0 to R. This is the original format. But you already know. What you know? You know that NCR is equal to NCN minus R. This you already know. So use this. What to do? Use this. So using this, what you can say? Using this, I can write like this: K equal to 0 to R. I can write it NCN minus K, MCR minus K. Yes or no? Agree? The same thing you can write in different way, that K equal to 0 to R, NCK, MC, M minus R plus K. Okay, so basically the same thing you can write in different ways. For example, this one, 12C4. For example, this 12C4. Okay, this you can write. How you can write? I can write it from 6 you take K, from the remaining 6 you take 4 minus K, and so there are 6 men, 6 women. Okay, and this K is going from 0 to 4, right? But the same thing I can write like this also. K is going from 0 to 4. From 6 I am taking K, and from 6 I am taking how many? 2 plus K. Yes or no? Because 6 minus 4 plus K. So both are correct. Agree or not? So this Vandermonde identity, they can ask you in many different ways. They can ask you like this also. I can do 2 plus k summation k equal to 0 to 4. But all these are same. When you see the Vandermonde identity, I can guarantee you will catch it. Okay, whenever you will see this type of things, you will automatically get to know, you will okay that this is a Vandermonde identity. And this is the, and in the Vandermonde identity, if I take n women and men, then what will happen? In the Vandermonde identity, tell me, in the Vandermonde identity, if I take like this, n woman and men, then I can do from 2 n you want n. Then I can do like this. From these you take k, and from these you take n minus k, and summation, what? K is going from 0 to n. K is going from 0 to n. Okay, so you have n men and women, basically n men and women. So let's assume these are n men and these are n women. So finally you have total 2n. There are total 2n people. From 2n people you are wanting n people. So I can say you can take k, and from there you can take n minus k. K is going from 0 to n. But can you notice these two things are same? Yes or no? nck is equal to nc n minus k. So I can write also like this. This is another way of writing nck whole square. nck whole square. So this is your another. So okay, so this is also important. Basically you have n boys and girls. This is your story. This is hint for the story. Means you have n boys and girls and you are selecting n people. Very simple. Yes or no? So did you understand all these stories? Can you create these stories? Like how will you, okay, what story you will create for this? Can anyone give me one story for this? Very simple. Please give a story for this. For this you give a story. When you look at this, what story will come to your mind? It means I am selecting two people. It simply means I am selecting two people. It simply means n boys and girls and two people you select. Yes or no? N boys and girls and two people you select. Yes or no? This story will come to your mind. So what story will come to your mind? There are n boys, there are n girls, select two. Select two. Then what is the side one? Side one of this story, total 2n people you have and you want to select two. This is side one of the story. What is the side two of the story? What will be the side two of the story? Both can be boys. See, side two of the story, both can be boys. Both can be boys. Means what you do? NC2. Means what you do? NC2. So both can be boys. So n boys are there. Both can be boys. Or both can be girls. Or both can be girls. Correct? Yes or no? So again NC2. One boy, one girl. One boy, one girl. So that will be what? One boy, one girl. That will be NC1, NC1. That will be NC1 multiplied by NC1. So can you notice both are this is the proof. Side 1 is equal to side 2. So I can say from 2n people you are selecting two people. From there are n boys and girls. There are n boys and girls and you are selecting two people. So I can say this is nothing but both can be boys. If both are boys, then NC2, or both are girls, then NC2, or one boy, one girl. So that will be n square because NC1 is n. You already know NC1. NC1 is n. This is nothing but n. So this is your story. Tell me, are you getting how to create a story? Are you understanding how to create a story? Please tell me. Okay, so that's it. So this is all. So I hope you understood this. In the GATE exam, whatever they ask you, you can create a story. Whatever they ask, just create a story. These are standard. All the things that we have seen, all these are standard stories. Let me tell you, it's not like there are some more complicated stories. There can be more complicated stories, but from GATE exam point of view, all the stories that we have seen, these are enough. Only these stories you have to use. One more story we will create in the next class, one last story, okay, that we will do in the next class. On that story we will also solve one gate question. There is a gate question on that story that we will do in the next class.